All right, so for doing this first one here, we're finding out what f of 3 is. Now, that means that we're taking the 3 and plugging it in for x wherever it appears. So that means we're plugging it into all of those locations. So step 1, make sure you write this on your paper. F of 3 equals negative 3 squared minus 3. Now, a little bit of detailing work. This is actually where the difference is going to come in between this problem and the next one. We're doing negative 3 squared. Notice the negative 3 is inside the parentheses, so we're actually squaring negative 3 in this case. Now, negative 3 squared means negative 3 times negative 3, and a negative times a negative is a positive. Absolutely. So that ends up being 9 minus 3. Notice a positive 9 minus 3, which of course is 6. All right, now having done that one, we approach the second one the same basic way. I start by plugging that 5 in for x. So that gives me negative 5 squared plus 2 times 5. But this one actually means something different. In the first problem, we read this as negative 3 squared. In this problem, I read this as negative 5 squared. But they mean different things, because in the first problem, we were squaring the negative 3. In this problem, I'm squaring the 5, and then I'm applying the negative to it. That's what those parentheses do or don't do for us. So I'm going to do 5 squared, which is 25, and then apply the negative to it. Now, in terms of order of operations, the reason why is because negative 5 squared is exactly the same as a negative 1 times 5 squared. And if you think back to order of operations, you know PEMDAS, the exponent comes before that multiplication. And so that's why we got to do the 5 squared and then apply the negative to it. So last thing we do now, we do the negative 25 plus the 10. That ends up giving us a negative 15, so then that's our final answer. All right, so now we're going to be doing f of x equals 5 minus x, and we're notice plugging the negative 8 in for x. Now, one thing that sometimes that gives people trouble on is that gives us minus a negative. Sometimes we see that minus and we already think that we put it in there. So make sure that it's actually still the minus, and then it's the negative 8. All right, so now they got 5 minus negative 8. Now I got to figure out what is minus a negative. Now, if you have a little trouble with that rule, let me again give you a visualization using a number line to see how it is what it is. So there's my number line. I'm starting at 5 on this problem, and minus normally means I start by going to the left. But negative means switch it to the other way. So instead of going left, it actually ends up going to the right. So it's the same as 5 plus 8. And 5 plus 8, of course, is 13. All right, for the second one now. I start the same way. I start by taking the 10 that's in the parentheses, and it goes in for x in the original equation. Now it's a matter of evaluating that using the order of operations. And again, think about that order of operations. PEMDAS. The first thing I need to do in PEMDAS is the P. What does the P stand for? Parentheses. Parentheses, absolutely. Now, in this case, there actually are parentheses, although you may not necessarily recognize them as much, which is why I want to bring this up here. The absolute value brackets act as parentheses here. So the very first thing I need to do is the 10 minus 12, and then the absolute value of that. So 10 minus 12, negative 2. Now I do the absolute value of negative 2, which is what? 2. And yet notice what my work says here. It says negative 2 plus 8. Because I had that negative out in front of the absolute value. After I took the absolute value of negative 2, it was still hanging out there. That is that negative right there. So yes, the absolute value made it positive, but then the negative that was outside of it then makes it into a negative. It flips it after we take the absolute value. So now that I have negative 2 plus 8, I can go ahead and do that. That gives me 6. So f of 10 equals 6. Final answer right there. Next up, I'd like you to please evaluate each of these 3 division problems. All right, so for doing these, 36 divided by negative 4. Now, if you remember your times tables well, these are pretty easy. So for instance, 36 divided by negative 4, that's really saying negative 4 times what equals 36. So 4 times what does equal 36? 9. If you know your times tables, you know that right off the top of your head. So we got a 9 up here, and a positive divided by a negative gives us what? A negative. So then it's got to be a negative 9. All right. Next up, I'm doing negative 27 divided by 9. And again, that's like saying 9 times what equals that negative 27. So times tables, it's got to be 3. And a negative divided by positive, yes, is negative. So it ends up giving us negative 3 there. All right, and then we do negative 42 divided by negative 7. And again, if you know your times tables, it's pretty simple and straightforward. You're going to just remember it off the top of your head, because 7 times what is 42. But I keep saying it's easy if you know your times tables, but what do you do if you don't?
Use a calculator.
I'll show you a trick. Because we don't want to rely on calculators, because a lot of these things come up so much that if you're always relying on a calculator for them, you're going to end up wasting a lot of your time just trying to dig that thing out rather than just knowing it. All right, so first of all, a negative divided by a negative is what? Positive. So we know this is going to give us a positive number. All right. So if you don't remember 7 times what is 42, I can actually break the 42 down into a couple pieces that make it more manageable. What if I wrote the 42 as 2 times 21? Because 2 times 21 is 42 here. Now, the reason why I wrote it this way is because what's 21 divided by 7? 3. And so then this is just 2 times 3. And 2 times 3, of course, is 6. Which if you know the times tables right off the top of your head and find that easy, then you already knew that. But you didn't necessarily have to remember 6 times 7. If you remembered 3 times 7, that would help you get there. So again, you can still break down numbers to make some of these problems a lot easier on yourself. Now, sometimes the trick in doing that is knowing what actually can we divide a number by. So that's what we're going to practice now. All right, so in this problem, we're being asked which of these numbers are divisible by 2. Now, how do we know if something's divisible by 2? It's even. And we know it's even because the last digit is even. And that's all we got to look at is just the one last digit. So like in 20, is 0 considered to be even or odd?
Oh, it's even. Odd.
It'd be considered even. And so is 20 divisible by 2? Yes, it is. It happens to be 10, right? So 35. Is 5 even? No. Therefore, it is not divisible by 2. 94. Yes, the 4 is even. 55. Nope, the 5 is odd. 108. Yes, it is. 72. Yes, it is. 8,284. Yes, because all 3 of those end in an even number. And so that's really all we got to look at. So if I continue through this, 150, yep, 216, 381, 400, 49, 146, 22, 84, 38, 63, and 28. Now let's take it up a notch. How can you tell which ones are divisible by 3? Now, to know if they're divisible by 3, we cannot just look at if they're even or odd. But there are other ways we can know. Let's just start looking through them. 20, is it divisible by 3? No, because if I know my times tables well, I know 3 times 7 is 21. So I can get close to 20, but I can't actually get to 20, so no. How about 35? Is that one divisible by 3? Well, I know 3 goes into 36. That's too close to 35, so no. What about 94? Well, they start getting a little trickier here, right? This is where we're going to need to have a little extra knowledge. So that's where I get to share that with you here. Whenever you want to know if a number is divisible by 3, there's actually a cool trick that works just with 3. Add the digits together. What is 9 plus 4?
13.
It is 13. Is 13 divisible by 3? No. 13 is not divisible by 3, therefore 94 is not divisible by 3. So if you add the digits together and it divides by 3, the original number is divisible by 3. Now this only works for 3's, but it does work. So 55, is that divisible by 3? No, because 5 plus 5 is 10, and 10 is not divisible by 3. 108. Yes, because 1 plus 0 plus 8 is 9. And 9 is divisible by 3. 72. 72, 7 plus 2 is 9. Yes, that does work. 8,284. Well, that one's a little bit more work to add them. 8 plus 2 is 10. Plus 8 is 18. Plus 4 is 22. Is 22 divisible by 3?
No.
No. So neither is 8,284. 150.
Yes.
Yes. 216. 2 plus 1 is 3, plus 6 is 9, so yes, because the 9 is divisible by 3. 381.
No.
3 plus 8 is 11, plus 1 is 12, so yes, because 12 is divisible by 3. 400.
No.
Nope. 49.
Yes.
4 plus 9 is 13. 13 is not divisible by 3. 146.
No.
Nope. 22.
No.
Nope. 84.
Yes.
8 plus 4 is 12.
Yep.
12 is divisible by 3, so yes. 38.
No. No.
63.
Yes.
And 28. Nope. Because that one adds to 10. All right, so there's a nice trick there that you can use to know if a number is divisible by 3. Makes your life a lot easier when you're having to find things to divide it by. All right, next up, what about being divisible by 4? Now, to know if something is divisible by 4, that basically means you can divide it by 2 twice. Because dividing by 4 is dividing by 2 and then dividing by 2 again. So what's 20 divided by 2?
10.
10. And what's 10 divided by 2?
5.
5. So that one works. That one can be done. And that's how we can know, is we look at each number and we see, can I divide it by 2 twice? Now, because of that, 35, can I divide it by 2 even once?
No.
No. In fact, all of those with odds we can rule out right off the top, because if it wasn't divisible by 2, it's not divisible by 4. So 94. If I divide 94 by 2, that gives me 47.
No. I can't. What?
47, can I divide that by 2?
No.
Nope. So not divisible by 4 then. Next up, 108. 108 divided by 2 is 54. Is 54 divided by 2?
Yep.
It is divisible by 2, yes, so that one works. 72, can I divide that by 4? All right, so 72, that one does work. 8,284, can I divide that by 4?
Yeah.
Yes, we can, because I can divide it by 2 and divide it by 2 again. 150? Nope. Because 150 divided by 2 is 75, and that's not divisible by 2. 216.
Yes.
Yep. 400.
Yes.
146.
Yes.
46 divided by 2 is 73.
No.
So no. 22?
No.
Nope. 84?
Yep. Yes.
38?
No.
And 28?
Yes.
Yep. All right, one last one to see what we can divide them all by. 5. Yep. Now this one hopefully is pretty easy.
Yeah.
Is 20 divisible by 5?
Yes.
Yes, it is. What about that number told you it's divisible by 5?
Ends with a 0.
It ends with a 0. Any number that ends in a 0 is divisible by 5. 35. Is that divisible by 5? Yes. What is it about that that tells you?
Ends with a 5.
It ends in a 5. So the rule is any number that you can that ends in 0 or 5 is divisible by 5. So 55, 150, 400 are all of them that can be divided by 5. None of the others can, because if it does not end in a 5 or a 0, it is not divisible by 5.